This math puzzle I'm going to show right here, I think is a very good example of why math puzzles are the best types of puzzles. If you want depth and complexity, and you want to learn about the world in which we live. This particular puzzle or math problem is very similar to other math puzzles on my channel because this has many layers. You can dig down through the first layer and then call it good, or you can keep digging and go to another layer and understand it even better. And then you can go to even another layer after that, and then an even deeper layer after that. And you can just keep digging through all these different layers to really understand this problem. So it offers depth, richness, complexity, and a very detailed understanding of the world and universe in which we live. I don't get graded on doing these problems. That's why I call them puzzles. They're just a mental activity, sort of like a Rubik's Cube or Sudoku. Okay, I'm going to jump right in and show the layers. First off, I'll start by presenting this as a puzzle so you can try to figure it out yourself if you want and pause the video. And then I'll reveal the answers afterwards. So here's a story to make this applicable or turn this into applied mathematics. Let's say this is some sort of World War II scenario. So it's pre-computers and electronics. So let's say there's a base somewhere in a foreign country, military base that is, and say it's in maybe a desert environment where there's lots of rocks and rubble and boulders and ravines, and you can see for over a mile in each direction. So some sniper keeps crawling out there at night somewhere in the darkness and keeps shooting at your base. But he's about a mile away, so far he hasn't hit anybody. But he knows that, so the purpose of his firing is what you call H&I, or harassment and interdiction. He's just harassing the people on the base and interdicting them so that they can't perform their duties or perform their missions. You can try to send people out to find him, but you have to cover over a mile in each direction. And it's dark, and there's no night vision goggles because they haven't been invented yet. But even if you had night vision goggles, there's just so much rubble and debris out there. Maybe there's a lot of bombed out buildings and whatnot. So there's just too many places a sniper could hide. It's just too easy for them to scurry around like a little mouse and hiding behind things everywhere they go. So you really need to send somebody out there and talk to him and tell him not to do that, because let him know that there's people on that base and he might end up hitting somebody and somebody might get hurt. And if that doesn't work, then you can just shell the area with artillery. I've often read that artillery is the best counter sniper method, because if you try to send somebody else out there to find him, then that person could get shot. So that means that person's going to have to stay hidden somewhere and just have like a little hole that they can look out of to try to shoot at the sniper. But that doesn't give them any field of view, and that takes a really long time, and the two snipers may never find each other. So the best method is just to shell the area with artillery. Okay, so after a few nights of this happening, the base finally gets some artillery brought in, and they're going to start using it that night. As soon as the sniper starts firing, they're going to try to listen for the sound, guess where he is, and start shelling the area. But then maybe this could be some sort of a MacGyver type scene. So some smart engineer guy says, hold off on that artillery, don't start shelling the area yet because we don't want to scare him off. So once it gets dark and our men can move through the cover of darkness without being seen, send out about 30 or 50 guys all throughout the area. Each one can have a watch that is synchronized down to the second with everybody else's watch. And just hang out and wait for the sniper to start shooting. Once the sniper shoots his first shot, then everybody get ready and start looking at their watches. And as soon as he shoots his second shot, then everybody write down the time to the second that they heard that sound. We'll give everybody the precise locations where they're supposed to go, so they'll be spread out evenly. And as soon as we're able to triangulate the location of the shooter, we'll radio that location to everybody. And then everybody will know to scatter away from that section as fast as possible, because we're going to start shelling it. And I figure you'll want to send the guys out in groups of 2 or 3 or more for protection, just in case they run into a small enemy squad. So with all those large numbers of people we just sent out into the field, there's going to be a pretty good probability that a lot of them are going to hear that sound at the same time according to their watches. So some of them will hear the sound at 9:08 and 3 seconds. Some will hear the sound at 9:08 and 6 seconds, or 8 seconds, or whatever. And with so many people in the field, it'd be a good idea if you had several frequencies for your walkie-talkies, and that way they could all radio back their times at once. And then you could get all those times written down really fast and triangulate the location of the shooter. Okay, so that's the story. Pause the video if you want to try to solve this and find the location of the shooter just by using these numbers. And I'll show a pretty big clue on the next page. So here we go. If we have a circle, take any 2 points on the circumference of that circle and connect them with a line. Find the midpoint of that line and then draw a perpendicular bisector at that midpoint. And that perpendicular bisector will pass through the center of the circle. So this is the first level of understanding, or the first level of teaching. This is how they could teach this in a geometry class. This is how I've seen it taught. The first level of teaching, or first level of knowledge or knowing, is just saying that the perpendicular bisector will pass through the center of the circle. Now you can take it up a notch and dig down to the next level of understanding and realize that if you have 2 pairs of these locations right here, then they will both pass through the center of the circle, and where those lines meet, that will be the center of your circle. Third level of understanding is how you can make a story out of this or turn this into applied mathematics. So what this means is, if there's an explosion or a gunshot at the center of the circle, or at this point right here, that sound wave will spread out radially. So the people on the smaller circumference here, no matter where they are, they will hear that sound about 3 seconds later. And then the people on the larger circumference will hear the sound 4 seconds later. Sound is carried in the wind because it's air molecules. It's a compression wave where the air molecules are pushing against each other. So if the wind is blowing 15 miles per hour, then that will increase the speed of sound in that direction by 15 miles per hour. And then any sound waves traveling against the wind will be slowed down by about 15 miles per hour. But the speed of sound is over 760 miles per hour. So this is a very small percentage of change, somewhere around 3 or 4% or so, depending on the speed of the wind. Okay, so using this knowledge right here, are you able to solve this puzzle right here and find the location of the shooter? All this is, these are just points on the circumference of a circle. I just drew in a light pencil mark and then measured out like 3 centimeters to a couple of points, and then 6 centimeters to a couple of points, and so on from that pencil mark. And then I erased the pencil mark so you won't be able to see the center of the circle. I'll go ahead and show how you can connect these points here. So 3 and 3 is going to be on the same circumference, 8 and 8, and so on. I'll connect them right now. What I did right here was measured out everything as accurately as possible, or at least as accurate as you can with just a ruler that has millimeter markings. And I didn't want to connect everything artificially in the center as if all the measurements were perfect. Because what this shows is, if you're just off by half a degree or a degree or so, or a millimeter or 2 on your markings for your perpendicular bisector, this shows how you'll be off. This also shows why you want to get 3 separate pairs of microphones, because if all I had were the microphone pairs of 6 and 6 and 3 and 3, then they would meet way out here, and I would have a large circle or a larger radius, which isn't as accurate. But by having a third pair, which is 8 and 8, now I can look and see where the rough area is, or approximate area where they all intersect. And this also shows why you want to put your microphone pairs perpendicular, because notice here 6 and 6 is sort of parallel with 3 and 3. Thus, their perpendicular bisectors will be almost parallel. Thus, when those perpendicular bisectors connect, they're going to miss the mark quite a bit. But by making your microphone pairs perpendicular, then they're all going to connect closer to the center of the circle. And this little space right here in between all 3 pairs, that's only a couple of millimeters or so. Okay, so that was the third level of understanding, where I make a story out of it. And then on the next pages, I'm going to dig deeper and show more levels of understanding. The complexity of this problem just seems to go on, and that just makes it really fun, because you don't have to keep digging. You can always stop whenever you want, but there's always more there if you want to keep digging and learn. The fourth level of understanding will be to show the errors That's what I wrote right there. So this is to show how you can have errors on this. In the real world, you're never going to have exact numbers when you're measuring something, whether it's velocity, mass, or distance or whatever. So you're always going to have to round in the real world. So maybe the rounding is done by a computer, or maybe it's done by yourself. And you're likely going to have some errors if you just send a bunch of people out into the field with synchronized watches. So I have right here an explosion that happens in the center of this circle. The people on this circumference will hear that sound at about 3 seconds. Sound travels at about 1 mile every 5 seconds. So here we have some people. Out of all those people we sent out to the field, we sent out like 50 groups or so that had synchronized watches. And out of all those people, we got back 3 pairs of watches that had the same times on them, down to the second. So let's look at those 3 pairs of watches. The people right here on this circumference of 3, that means they're going to hear the sound or hear the shot 3 seconds later. They have accurate times on their watches, or pretty accurate, so there's a person here and a person here, or a microphone here and a microphone here. Draw your line connecting those points, find the midpoint on that line, and draw a perpendicular bisector, and it will pass through the center of the circle. But that's not enough information because that means the sniper could be anywhere along that path. Now here's where I show some errors. This person right here was 3 seconds away, but they thought they were 4 seconds away. So let's say the person thinks that, or what we think is that this is 4 seconds and we think that this is 4 seconds. So we connect those 2 points because we think they're the same, even though they're not. You can tell they're shifted to the left or to the west by a couple of centimeters or so on this scale. Draw your perpendicular bisector, and thus you're going to miss the point by about 1 or 2 centimeters or so, because like I said, your line has been shifted to the left, so your perpendicular bisector will be shifted to the left. And we have another error here. We have a 3 and a 4 that got connected because we thought those were the same times. They happen to be 180 degrees from each other on this circle, so their line will pass right through the center of the circle. Previously, I thought that way we could find the sniper, because we know since this line passes through the center of the circle, we'll know that the sniper is right there. But that is not correct because we did not draw our perpendicular bisector. So these microphones here, this line segment has been shifted down by a couple of centimeters because I'm connecting this point and this point. So everything got moved down, thus the perpendicular bisector will be moved down as well. And we're missing the shooter to the south by about 1 centimeter or so on this scale. Now what we're going to do is connect these 2 points because we think they're the same, but they're not. Draw your perpendicular bisector, and you're not even in the ballpark. You're on the edge of town or outside of town. This perpendicular bisector will go nowhere near the shooter. And that's because these points are way too close, so everything got twisted. So that's a lesson there that shows us we need to have our microphones. If you have 2 mics in a pair, then each of those mics need to be as far away from each other as possible. And that will mitigate some errors. Look at what we have here also. This pair of microphones right here and right here is parallel to this pair of microphones right here and here. Thus, their perpendicular bisectors will be roughly parallel. They're not going to be exactly parallel, most likely, so they will connect with each other. But when this perpendicular bisector A finally connects with B, these lines are almost parallel, so when they finally cross each other's paths, they're going to be miles away. So if we try to looking at that point, if we try to look at the point where those 2 perpendicular bisectors meet, we are going to be way off the mark and nowhere near the shooter. So this shows your microphone pairs should not be parallel, they should be perpendicular to each other. So we have this pair and this pair that are parallel, but then we have this pair right here that's perpendicular, and that's what gives us our answer. Because if the microphone pairs are perpendicular, then their perpendicular bisectors will be perpendicular to other pairs of microphones, and we're going to get a lot closer to the mark. So this was the level 4 of understanding on how you can get your errors. If you just want to talk about how this can cause errors, so you can say, well, it's inaccurate, you shouldn't use it. But level 5 is the final level of understanding that I've came across, or the deepest level. This is how you can still use this method if you ever had to, like for a MacGyver show or something, and you can still mitigate your errors. If you were to see this method used in some sort of MacGyver fan fiction or something, then they likely wouldn't go into the details about how you can get these errors and how to mitigate the errors. It would just show somebody sitting down, drawing out some perpendicular bisectors, and everything would meet right at the center of the circle, and you would know the sniper is right there, so somebody can go out and talk to him and tell him not to do that. Okay, so fifth level of understanding to mitigate your errors. The two mics that are in a pair must be as far away as possible from each other. Thus, we have this point right here, perpendicular bisector C. These two mics are way too close, and so whenever you have your errors, what this does, it causes a twisting of your line. Thus, it twists your perpendicular bisector way off course. And I said here, your mic pairs must be as close to perpendicular as possible so that the perpendicular bisectors will be perpendicular to each other. And this also shows that you need 3 or more pairs of microphones, and the more pairs you have, the better. Because what's going to happen in reality is you're likely not going to get all of these perpendicular bisectors meeting at the exact center of the circle. They're all going to meet somewhere in an area there, so that will give you the area. So let's say you send somebody out to talk to the guy and tell him he shouldn't do that because he could end up hurting somebody, and let him know that there's people down on that base, and maybe he didn't know that. But then if he wants to keep shooting and you have to shell the area, now you have a very precise location right here. I've read that the artillery from the M777 has a lethal radius of about 50 meters and a severe injury radius of about 100 meters. So that would mean if an artillery shell landed on a goalpost at one end of a football field, the people at the goalpost at the other end of the field would likely be injured. So that's a pretty big radius. And with this method right here, with just some synchronized watches, you could theoretically nail down the location to a radius of just a few hundred meters. But like I said, if this were a TV show, there would be no errors, and everything would drop right on the center of the circle.